Let f of x be equal to a numerator divided by a denominator, where the numerator can be either a function of x or it could be a constant, and the denominator must be a function of x. If that's the case, and there are no common factors that factor out and cancel, right, then this function will have a vertical asymptote when the denominator is equal to 0. So it would, this is how, let's consider an example to see how this would work. So for number 1, let's consider f of x is equal to 1 over x, right? If we graph this function, we will see the following. X, y, and it looks something like this, and like this on this side. And we see that it has a vertical asymptote at x equals 0, and that makes sense. If we set this equal to 0, which is the denominator, then it has a vertical asymptote, and we see in fact that that's true. And we see that the function blows up, that it gets very big, right, at x equals 0, right? And in fact, the function is undefined at x equals 0 for the following reason. Let's say we let x be equal to, let's start with 1, x equals 1. So 1 divided by 1 is equal to 1. And then let's let x be something smaller than 1. So let's let x equal 0.5. So 1 divided by 0.5 is equal to 2. And let's just keep going small. 1 divided by 0.1. 1 divided by 0.1 is 10. Let's let it be something smaller than that, 0.01. 1 divided by 0.01 is 100. Let's let it be something still smaller. Let's go 0.001. 1 divided by 0.001 is 1,000. Right? Okay, so we see that the function values are getting bigger and bigger and bigger. And so they're going to infinity. They're getting really big. If you divide by something really small, 1 divided by 0.000000001, then you're going to get a really big function value, right? Something very big. And so we see that the function is going to infinity. But the function is undefined there because 1 divided by nothing doesn't make any sense. It doesn't make any sense to divide by nothing. So mathematically, we say that the function is undefined at 0, but that the function goes to infinity at x equals 0, right? It's tending, it's in the limit, it's going to infinity. Okay, so that's the first example. Let's consider the next example. So I've graphed a function here, and we'll write down what this function is now. So this function graphed, this is f of x is equal to x divided by x squared minus 1, like so, right? So to find the asymptotes, and we see that they're at -1 and +1, right? So let's see if our idea works of setting the denominator equal to 0, if it'll match up with this graph that we've graphed. And you can always graph them with your calculator to see where they'll show up, right? So let's take the denominator, x squared minus 1, and set it equal to 0. So x squared minus 1 is equal to 0. Add 1 on both sides. And this cancels here. And we have x squared is equal to 1. Take the square root of both sides, and we see that x is equal to, when we take the square root, we have to do the plus or minus, right? Plus or minus, and then the square root of 1 is 1. So this is plus or minus 1, like this, right? So we see that the graph that we graphed with our calculator is matching up to what we derived analytically, right? We set this equal to 0, and then it followed that x is equal to plus or minus 1. And we see the asymptotes at -1 and at +1. And we see that the graph the function is getting really big, right? Really negative infinity, it's blowing up to negative infinity right here, it's blowing up to positive infinity here, negative infinity right here, and positive infinity there, right? Okay, and in fact, the function is undefined at those places, at -1 and +1, because it doesn't make any sense. Whenever this whole bottom thing is equal to 0, it doesn't make sense to divide by 0. The third example will be the following. Well, let's let f of x equal to x divided by x squared plus 1, like so, right? Well, whenever we do that, let's set the denominator equal to 0, so we have x squared to find the vertical asymptote. Set the denominator equal to 0, x squared plus 1 is equal to 0. Subtract 1 on both sides, and we get x squared is equal to -1. Well, to solve this, you would have to take the square root of both sides, right? But the square root of a negative number is imaginary. There's no number that will satisfy this equality. No number times itself is equal to -1, right? And so therefore, even though we set the denominator equal to 0, there is no vertical asymptote, because the vertical asymptotes are imaginary vertical asymptotes, if you want to think about it that way. And so they don't exist. And so there won't be any vertical asymptotes for this situation. So let the mathematics speak to you, and it will tell you what the right answer is. I'm going to step out to the side and give you a clear screenshot. We're going to do horizontal asymptotes next.